of 8051. In block diagram of 8051, it is very very important to understand each and every block of the architecture of 8051 microcontroller. Why? Because without knowing hardware, we will not be able to develop any application on the microcontroller. Here we can see different blocks. Okay, what are the different blocks? Let us see one by one. Okay, first and foremost, we are having the heart of the microcontroller which performs different operations, that is arithmetic and logical unit. Okay, arithmetic and logic unit is basically here 8-bit in nature. That means all the operations that is working on microcontroller is 8-bit only, like addition, subtraction, multiplication, division, and other logical operations like OR and XOR, complementing, clearing, setting the bit, setting the byte, everything is done on ALU. Okay, so this ALU is supported by few registers called as A, B, PSW, and two pointers called as PC and DPTR. A, B are general purpose registers, each are of 8 bits. PSW, program status word. PC, program counter, and DPTR, data pointer. Out of this, A, B, and PSW are 8-bit in nature. PC and DPTR are 16-bit in nature. Next, we have the next part, that is basically the oscillator circuit with a crystal oscillator. Basically, 8051 works with a theoretical speed of 12 megahertz, practically 11.0592 megahertz. This is the working speed of a microcontroller, right? So, I am connecting the oscillator to the circuit at a particular pins through the capacitor to have a proper square wave being generated to work as a clock input to the microcontroller. Next block is basically the ROM, read only memory. Here the memory is about 4 kilobytes available on chip. As the name itself is saying, it is read only memory. That means whatever the data is written, whatever the information is written there, it is permanently stored. Usually we prefer ROM for storing program. Why? Embedded system is going to perform the same task again and again. Hence, we store code in the ROM memory. Next, we have RAM. RAM is of 128 bytes, ranging from 00 to 7F. RAM read-only memory is used, basically chosen to store data. There are different sections in RAM. Basically, register banks made up of 7 registers each. We have 4 such register banks. Bit addressable memory, where each location houses 8 bits and each bit is individually addressable. And we have general purpose storage or general purpose area. Here all we are storing the data preferably. Next important block is basically here SFRs, special function register. These are also registered, but they have a specific task to perform. They basically have 8 bits. Each and every bit have a described function. For an example, we have TCON register, TMON register. These two controls the operation of timer and counter. We have IE, IP, interrupt enable, interrupt priority. These basically control the things related to interrupts. Similarly, we have SPUF where the data is serially stored temporarily, buffered temporarily. Next block basically is timer and counter. If you are generating a delay or if you are counting an internal clock pulses, the peripheral is said to be working as a timer. If you are counting an event or any external input, then we call the peripheral to be a counter. We have two timer counters T0 and T1, each are of 16 bit. Okay, so each are of 16 bits. So that means I have totally 32 bits available to work as a timer counter. You can make it work as 16 bit, 32 bit, 8 bit, likewise. So you can select different modes of the operation. Now, microcontroller has four input output ports. Input and output, they are multifunctional. P0, P1, P2 and P3. Okay, so each of 8 pins, and they are going to communicate to the other parts of the devices also. Now these four ports are all parallel ports. That means all 8 bits are sent or received serially. Wherein not all the time a user prefers a serial port. Sometimes we might also need a parallel serial operation for the circuit for being more efficient. Not all the time we prefer a serial port. We might also need a serial operation, not parallel is preferred always. So serial operation is done using a serial port. Whenever I'm transmitting the data, I call it as TXT or a transmitter. Whenever I'm receiving the data, I'll call it as RXT or receiver. Whenever there are different operations happening, okay, I need a bus controller which decides. The bus is either acting as an address bus or a data bus. Okay. Now, some operation is going on in a microcontroller. All of a sudden, you want to interrupt the entire process. This process is done through a signal called as interrupt. There can be internal interrupt, there can be an external interrupt. So to control this kind of an interrupt, we need one more block called as interrupt controller, which is going to perform different operations called as interrupt service routines. This is a brief explanation on the block diagram. To just summarize the key features, 8051 is 8-bit processor, 8-bit ALU CU. We have 16-bit address lines and we have 8-bit data line. We have a program counter which points to the next instruction and the program counter is 16. We have data pointer which points to the memory where the data is stored, which is called as DPTR. Each of these PC and DPTR are 16-bit each. We have a stack memory and a pointer to stack memory is called as stack pointer, which is of 8-bit. Always stack pointer is preloaded with the value 07H. We have different special function registers called as tmod, tcon, scon, pcon, sbuff, IE and IP. There are two timer counter registers represented as T0 and T1. The basically microcontroller is built on a hardware architecture. That means it has a separate address and data memory. It is built on complex instruction set computer CISC architecture. 8051 facilitates two external interrupts from the external pin, INT0, INT1, both being active low signals. There are three internal interrupts, timer 0 interrupt, timer 1 interrupt and serial data interrupt. So in whole there are 5 important interrupts in microcontroller. There are special bit manipulation instructions in the 8051. Internal ROM size is 4 kilobytes. RAM size is 186 bytes. This is extendable up to 64 kilobytes of memory. RAM is bifurcated into 4 register banks. Each bank has 8 registers. There are 32 input-output pins, and the rest of the pins are basically used for special functions. So, in whole microcontroller is 40 pin IC. The circuit has clock and oscillator input. The circuit is full duplex model with UART serial interface. Basically, apart from this, the system might also house a modem, digital to analog converter DAC, analog to digital converter DAC, ADC, floating point processor, cache memory, memory management unit, direct memory access DMA, pipelining, and other stuffs also. So these are the key important features of 8051. Let us understand the rest in the next class. Thank you so much.